Welcome to this explainer. Today, we're taking something that, let's be honest, a lot of developers view as a total coding chore, and we're going to transform it into a legit superhero-level engineering skill, Python database error handling and transaction management. By the end of this session, you aren't just going to be writing code that works under perfect conditions. No way. You're going to be designing systems that survive when absolutely everything goes wrong. Okay, let's dive into this. What actually happens when a database crashes exactly halfway through a banking transaction? Picture this. User A is sending $100 to user B. The database deducts the $100 from user A's account, and then, boom, a sudden power loss, a severed connection, maybe a server timeout. The transaction totally crashes before the money is ever added to user B's account. So where did the money go? Well, without proper database error handling, that money is effectively lost in the digital void, leaving you with corrupted data and some very, very angry users. The stakes here are incredibly high. So here's our roadmap for today. We're going to cover 1. Why database errors matter. 2. The basic defense mechanism. 3. Catching specific exceptions. 4. Real-world banking scenarios. And finally, 5. Enterprise best practices. Let's get right into it.
Section 1. Why database errors matter. Before we even touch the syntax, we really need to understand the sheer magnitude of the problem here. Without a safety net, things go sideways fast. First off, your program crashes unexpectedly, which is just a terrible user experience. Second, your data becomes completely inconsistent. Third, just like we saw in our banking example, transactions can fail partially. But honestly, perhaps worst of all, sensitive info gets exposed. A raw error message could literally hand hackers a blueprint to your backend, stuff like table names or server details. So this isn't just about keeping the app running smoothly, it's about averting a total disaster.
Section 2. The basic defense mechanism. Let's move to and see how this builds. So how do we actually protect ourselves? Well, we use Python's core execution flow for error handling, which is the try, except, finally block. It goes like this. First, you try. You place your risky database operation right here, essentially telling Python, hey, attempt this. Second is the except block. If the operation fails, the app doesn't just crash, it falls safely into this block where you can handle the error gracefully. And third, finally, think of this as your ultimate cleanup crew. It always executes, whether the operation succeeded or failed, which allows you to release memory and safely close those database connections. Section 3. Catching specific exceptions. Now that we've got our basic shield in place, we need precision. Enterprise developers, they don't just throw a giant generic net over their code to catch any random error. They use precision tools. By identifying specific exception classes, you know exactly what went wrong. For instance, an interface error tells you right away there's a connector issue. A database error points directly to the database itself. An integrity error, that triggers for constraint violations, like if someone tries to sign up with a duplicate email. And a programming error reveals invalid SQL syntax. Catching these specific exceptions gives you exact control over the fix and dictates the exact message you send back to the user. Section 4. Real-world banking scenarios. And this brilliantly illustrates how we bring these technical tools into a high-stakes, real-world environment to solve that banking crisis we talked about earlier. But first, we absolutely need 2 lifesavers, commit and rollback. When you execute a transaction, those changes aren't instantly permanent. You have to call commit to permanently save them. But if something goes wrong midway through, you call rollback. This is basically a giant undo button that completely wipes away a partial transaction, restoring the database to the exact state it was in before you even started. Let's walk through the exact sequence of a rescued money transfer in action. We use our try block to attempt the transfer, deducting from account A, adding to account B. But suddenly, a connection fails midway. Instead of crashing, the process falls directly into our accept block. Inside there, we immediately trigger rollback. That partial deduction from account A, instantly undone. The money's completely safe. We then log the error internally and notify a system admin. 0 money lost, total data consistency maintained, and a massive crisis seamlessly averted in mere milliseconds. Section 5. Enterprise best practices. Now, what's really interesting about this slide is the sharp contrast between amateur and professional error handling. If we want to truly build bulletproof systems, we have to move beyond basic scripts. The bad practice? Exposing raw database errors directly to your users. If you show a stack trace to the end user, you are literally handing away your sensitive system architecture. The good practice, the enterprise method, is logging those errors internally using secure frameworks.
The user just gets a polite "something went wrong" message, while your secure internal logs capture the specific error codes for your engineering team to actually fix.
Another absolutely crucial security measure is how you handle your queries. Injecting user input directly into a raw query string is highly, highly dangerous. It leaves you wide open to SQL injection attacks, where malicious users can just delete or steal your tables. The safe enterprise standard is to always use parameterized queries. This treats user input strictly as data, never as executable code, which forms the absolute best defense to keep your application secure.
To quickly round out our enterprise toolkit, consider how these final practices ensure stability for massive systems. First, use connection pooling so you aren't constantly opening and closing costly server connections. Always close those connections properly, relying on that trusty finally block we discussed earlier. Implement retry mechanisms. If a database is just busy for a millisecond, don't fail immediately. Safely try again. And finally, use custom exceptions to map complex database errors directly to your specific business logic. This is how you ensure immense stability for huge high-traffic systems like ERP software or APIs. This is how you ensure immense stability for huge high-traffic systems.
So, the crucial point is this. Great developers don't just write code that works. They write code that fails safely. Database error handling is quite literally what makes applications stable, secure, and reliable. So ask yourself, are your database transactions ready to fail? Take a hard look at your architecture today and ensure you're using try except finally blocks, rollback commands, and secure parameterized queries. Thank you so much for joining me for this explainer, and happy safe coding.